Okay, that's the work for the problem, distributing the 3 through, collecting like terms, subtracting 39 from both sides, dividing both sides by negative 11. You should get x is 3. All right, we are halfway to the answer. Because remember, we're trying to find the x and the y that make both of these true, right? I have found the x. X is 3. Now, can anybody tell me where I'm going to get my y from? That one right there, right? The one I boxed earlier. I have an equation for y. It says y is 13 minus 3 times x. But I know what x is. So now I'm going to substitute this answer back into this one. So after you've substituted that and got an answer, you're going to substitute again. Answer into the first equation that you found. That was the one that we boxed. So let's go ahead and do that. Plug that in. What do you get for y? I'll do that up here. I'm going to rewrite this. Y equals 13 minus 3x, but I'm replacing the x with 3. So this is 13 minus 9, which is 4. So as an ordered pair, right? My answer as an ordered pair is the ordered pair 3, 4. 3, 4. That's my answer. That means if I plug 3 in here and 4 in here, I should get 13. So 3 times 3 is 9, plus 4, that's 13. But if I do 3 and 4 in here, I should also get 6. So 3 here would give me negative 6. 4 here would give me 12. Negative 6 plus 12 is 6, so it works. Okay, that's it. That's the way it's done. Now, let's go back to the problem that we stopped. And we.
The last part where you got to negative 11x minus 33, and I got a different answer. Aren't you adding 11 to the
No, you're undoing multiplication. This is multiplication, right? So you're undoing multiplication. You have to undo multiplication with division. So you're dividing both sides by negative 11, not subtracting. All right, so what were our supply and demand equations? We had P equals, let me see if I can remember this, 0.01x plus 5.8. And then it was P equals negative 0.005x plus 10. Remember those? We're about to solve this system of equations. And I'm going to put here the brace to let everyone know I'm about to do this. And I'm going to do substitution. So what is the first step to the substitution? What's your first step?
Solve either equation.
Solve either equation for either variable. Do you see anything that you like here? No? They're what? They are, you can set them equal to each other. You can do that. And that's what we're going to ultimately do, but let's see why. I get to look at the first equation and I can ask myself this question. Do I want to solve this for x? No, right? It's over here. I'd have to move things around. Do I want to solve it for p? It's already solved for p, right? I don't even have to do any work. It's already solved for p. This one is also solved for p. So either one of these I can pick, right? So if the first step is to pick an equation and solve for one of the variables, I'm already done. Okay? My first step is I have this equation right here. Okay? I have solved one of the equations for one of the variables. Well, actually, I didn't even have to solve it. It was already done. Now, what am I supposed to do with this answer? Substitute it, right, into the other equation that I didn't mess with, which will be this one, right? So I'm going to take this equation and I'm going to replace what with what? This right here, this p is going to be replaced with this, right? which is essentially setting them equal to each other. That's essentially what's happening. So I'm going to take 0.01x plus 5.8 and set that equal to negative 0.005x plus 10. Everyone see that? I've replaced this p with this expression. And then I get to solve that, right? Now, you can solve this, you can get your calculator out and you can do this, but I have a way of doing this. Might be a little easier without a calculator, and that's to get rid of these decimals, because decimals mess people up. So remember that when you multiply something by 10, what happens to the decimal point? It moves to the right once, right? I actually would like to multiply by something that would move the decimal point over 3 times to turn this into a 5. So I'm going to multiply not by 10, not by 100, but by 1,000. And I'm going to multiply everything, both sides, by 1,000. Essentially moving the decimal on every one of these 3 places. So what happens when I move this 3 places? This becomes 10x. This becomes plus 5,800. Y'all understand what I'm doing?
Yeah.
This one becomes negative 5x plus this one becomes 10,000. And that equation is just a little easier to work with.
So you just move the decimal with you?
All the decimals 3 places on every single one of them. And now let's get all our x's on one side. So I'm going to add 5x to both sides. I get 15x plus 5,800 equals 10,000. And subtract 5,800 from both sides. So that should be what, 4,200? 10,000 minus 5,800 is 4,200. And finally, divide by 15. Who's got that for me? What is it? 280? Sounds right. X is 280. Now we're not done. We now need to go find what? The y, or in this case, p, right? And we can use this boxed equation to find p. So now I'm going to substitute that in. P equals 0.01x plus 5.8. So P equals 0.01 times 280 plus 5.8, which means P equals, what's that going to be? 0.01 times 280. 2.8 plus 5.8, which is 8.8? 8.6. 8.6, thank you. All right, can you write this as an ordered pair? I want you to be very careful right now. What's your ordered pair going to be? 280, good. And then 8.6. Now, can anybody interpret that answer?
When the cost is $8.60, this is fine. The demand is both $280.
That's right, perfect. So this is telling you that if you can get your prices for your oranges at $8.60, you're going to have not only a supply of 280,000 oranges, but a demand of 280,000 oranges, which means that your supply and demand are equal, which means you're going to sell everything that you produce. And everything you supply is going to be consumed. No waste at all. All right, good. Did that seem to go okay? I mean, you're going to have to get your hands dirty with these problems. All right, we're going to do another example out of the book. I'm holding off on elimination. I'm not quite sure if I want to show you elimination or not yet. I will show it to you at some point, but I'm holding back on elimination right now. All right, I'm going to do example 7, page 182. At a price of $1.88 per pound, the supply for cherries, okay, cherries, sure, is 16,000 pounds. And demand is 10,600 pounds. If the price drops to $1.46 per pound, supply is 10,000 pounds, and demand is 12,700 pounds. This problem is exactly like what we just did, right? Exact same setup, pretty much. The questions are a little bit different, though. Part A, find price supply. Part B, find price demand. And here's where things are changing. Part C, find supply and demand at price of $2.09 per pound. I'll skip over D. E, find the equilibrium price. All right, what time did we end? 45. Oh shoot, I thought we went till 11 something. Dang. I don't know, I can't. I told y'all most of the classes I teach are the calculus classes, and they're an hour 40 minutes. So I'm so used to having more time. It's like we're almost done. I wrote all that for nothing then. What's that? You did too. Yeah. Well, it's in your book too. So let's do this. How about? I think you'll like this. Let's do this. I'm going to change some of the numbers here. Okay, I'm going to change some of the numbers, and I'm going to make this a take-home quiz. And this will go in place of the in-class quiz that you would have taken on Thursday when you walked in. All right? So, and let me add something for Part D here. Find supply and demand.
So we're going to do just example 7 now?
No, I'm going to change the numbers. Yeah, I wouldn't give you a take-home quiz that's exactly in the book. So let's change this 188. Let's change this to 195. Everything I'm changing in the problem, I'll put in a different color, red. And let's change this to 13,000 and this to 8,500. And then at 146, let's change that to 156. Let's change this to 9,000 and change this to 11,300. There you go. If you want, you can just take a picture of the board. All right, that is going to be due at the beginning of class next time. Find the price supply equations. These are equations. Equation. Find the supply and demand at a certain price, then a different price, and then the equilibrium price. That means you have to solve a system of equations. I can guarantee you that the answers to this are going to be nasty. They're going to be decimals because I made up the problem. I know that the numbers are not going to work out nice. So if that's happening, please expect that, okay?
Is that the only homework for tonight?